Thank you, everyone. Hello. I'm Goutham. I'm a product manager at Grafana Labs for all things OpenTelemetry, but this only changed last month. Before that, I was a maintainer for Prometheus. I've done a lot of Prometheus, hosted Prometheus, Cortex, Mimir. But for the past year or so, I've been working on all things OpenTelemetry, but focusing on the Prometheus OpenTelemetry bridge. And today, I'll be talking about building an APM with OpenTelemetry and OpenSource. So yeah, let's get started. So I'm going to cover what OpenTelemetry is, what an APM is, and I'm going to go through a live demo, fingers crossed. And then I'm going to talk about what you can do to kind of implement this and what you will run into and what's coming up. Cool. So what is OpenTelemetry? But before I explain what OpenTelemetry is, I kind of want to explain the problem that OpenTelemetry is trying to solve. So let's say you're a big company, and you've evaluated all the observability vendors out there, and you picked one of the best vendor out there. And then you tell your developers, hey, you know what? This is our observability vendor. Let's go and instrument the services. Soon, there'll be developers instrumenting their services with metrics and traces for this vendor. And this is going to be great for the next year or two. Maybe in a couple of years, there's a new shiny observability vendor that comes out that you want to migrate to. Or maybe the existing observability vendor increases their pricing 50%. Now you decide to do another evaluation. You pick another observability vendor. Now you try to move to that vendor. And this is where you're stuck, because you have to go tell your developers to re-instrument all their applications again with this new SDK that produces a new set of metrics. Even if you're using like an auto-instrumentation agent, like a Java agent next to your applications, moving from vendor 1 to vendor 2 might have the same data, but the metric names are all different, the labels are all different. You have to relearn everything on how to debug your applications. So that is what OpenTelemetry is trying to solve, or like part of what it's trying to solve. So it's a collection of tools, APIs, and SDKs that you can use to instrument your applications. And the idea is you instrument your applications with OpenTelemetry and send the data to a collector, which is a pipeline. And from the collector, you can write to any vendor possible. And the really cool part about OpenTelemetry is that it supports almost all the serious vendors out there. So if you want to move from vendor A to vendor B, all you need to do is change configuration in this central pipeline to also send to vendor B. You don't need to change anything in your applications, and all the same metrics show up in vendor B. And now you can train your developers on using the new vendor rather than asking them to change their code and things like that. Cool. So OpenTelemetry is a set of standards, specifications, and conventions. And it also has implementations for those standards in the form of client libraries. And there is the middleware, which is the collector that I talked about. As part of the standards, they have the API SDK specification as to like how language SDK should look like. But they also have semantic conventions. These are conventions that tell how, like, what data you should collect in the form of telemetry, what the metric naming should be, what the attribute naming should be, and things like that. And finally, if you instrument your applications with OpenTelemetry, the applications will export all the telemetry in the form of OTLP, which is the OpenTelemetry line protocol, which you can then, in the collector, say, oh, take this OTLP data and send it to any vendor that you want. And then also, we have the client libraries and the implementations. So you have the language-specific SDKs. But what is really cool is you also have a really nice set of robust auto-instrumentation agents that come alongside OpenTelemetry. So you can focus on your business logic and let the auto-instrumentation take care of capturing all the relevant metrics, all the relevant telemetry like metrics, logs, and traces. Cool. It also has a couple of middlewares. One is the OpenTelemetry operator, which makes it easy to instrument your applications in Kubernetes. But then you have the OpenTelemetry collector, which can receive data from all kinds of sources, transform the data, aggregate the data, drop the data, and then send it off to whatever source you want. OpenTelemetry is not a storage backend. It's just the instrumentation and the line protocol. So typically, yeah, this is basically how it will look like. You have all your applications instrumented with OpenTelemetry, and then you send the data to collector, which writes it to a vendor. I mean, when I say vendor, it can also be a set of open source projects. Like anything, like almost all the major open source projects and vendors are supported by the collector. And if you want to migrate to a new vendor, all you say is, OK, in this central pipeline, which the infrastructure team operates, I will write to both so that the data exists in both places. I will slowly migrate my developers team by team to this new vendor, and I will shut down writes to the old vendor. It's just that simple. Again, training your developers is the hard problem here, but not rewriting your applications. Cool. With that, there is this very timely XKCD. Like, there are other observability standards out there. Why should I adopt OpenTelemetry? I could say, basically, OpenTelemetry is brand new. It takes care of metrics, logs, traces, and even profiles, and it makes sure there's consistent metadata across all three. And you can correlate between those. But that's not convincing enough. I think the biggest selling point of OpenTelemetry is the community. If you look at this, this is the activity inside the CNCF ecosystem. So on the bottom, you have the commits, and on the left, you have the PRs and issues. And OpenTelemetry is right up there. It's the second most active project beneath Kubernetes. And I think that's bonkers. Like, in the last year itself, there's like 20,000 commits and 45,000-ish PRs and issues that have been opened. The reason for this is, as an ecosystem, the observability vendors have come and stood behind OpenTelemetry, and they're now implementing all the functionality that OpenTelemetry requires. And if you look at it, you can Google any vendor, any project OpenTelemetry, and you will see that there's an integration for it. So I think that's why OpenTelemetry is winning, because of its community. And I think it is going to be a very big part of the future of observability. Cool. So with that, I kind of want to cover what an APM is. If you ask 5 vendors what an APM is, you get 5 different answers, sometimes 6, depending on which teams you're talking to. So I decided to contact the authoritative source on APM, which is Wikipedia. And Wikipedia is very useful. It says APM is the monitoring and management of the performance and availability of software applications. It's kind of so vague that I think 90% of the vendors in the exhibition booth do APM. But yeah, like APM means a lot of different things. So for this talk, I'm going to define APM my way, because again, I'm giving the talk. I get to define what APM is. So my definition of APM is, it's a system which will let you easily instrument your application, probably with an agent. And then you have a high-quality set of telemetry and dashboards exposed by this application that you can, by this framework or tooling that you can then use to monitor and understand what your application is doing. I want to highlight the part, probably an agent. You could have built open source APM before. Like, you have enough tooling, enough projects that do tracing, logging, and metrics, and you can kind of bring all of them together to build this APM solution on top of open source. But the really awesome part about an APM that I like is the instrumentation agent, where you just focus on your business logic, and then you drop in this Java or .NET agent right next to your application, and this takes care of instrumenting your application. It takes care of what to monitor, how to monitor it, and it kind of gives you a good, consistent set of telemetry signals across multiple different applications. You don't need to care about manually adding telemetry to it. Now, building a high-performance auto-instrumentation agent is really hard, which is why there aren't a lot of good auto-instrumentation agents out there in the market today, and that's changing with OpenTelemetry. The vendors are coming together and donating their proprietary agents to OpenTelemetry. They're adding their expertise to OpenTelemetry. And today, we have a really good set of auto-instrumentation agents that are only growing in quality with OpenTelemetry. I think that's one of the reasons I think you can do an open source only APM today with the help of OpenTelemetry. Cool. Let's see how this works in a demo. Again, fingers crossed. So basically, again, the OpenTelemetry project is massive, and they have a beautiful demo. I'm going to open that demo. Let's see. So there's a bunch of different services written in all kinds of weird languages. We'll see those languages pretty soon. But first, to the demo. So this is the OpenTelemetry telescope shop. The OpenTelemetry logo is a telescope. And then you get to buy a bunch of things. For example, I mean, I don't know, this looks expensive, so let me add to cart. This is typically how I shop. Oh, this is really expensive. OK, I need 3 of these. All right, so now that I have all of these, all this is previewed, let me do place order. OK, I've ordered this to 1600 Amphitheater Parkway. I am not sure where that is, but OK, it's OK. I bought it. It's fine. So this is the demo application, and all of this demo is in multiple different languages. We'll see what those are. All of this is instrumented with the SDKs and also the auto instrumentation agent. And then it's written to an OpenTelemetry collector that writes to Prometheus, Jaeger, and Loki. So here in Grafana, we've configured Prometheus for the metrics, Loki for the logs, and Jaeger for the traces. Both Jaeger and Prometheus are Apache 2. Loki is AGPL, but overall, I would say this is open source. Yeah, so I created 2 very exciting dashboards. First is the service overview dashboard, which kind of gives you a list of services. It looks super small. So this is not super fancy, because again, there's some limitations to the table panel in Grafana. We're working on fixing those. But you can see all the different services here, and all the different languages that these services are in. I'm able to generate this table because all these services expose the same metric. And I'm just building a table on top of this metric. So let me say, OK, I want to only look at Golang applications. Oh, I see there's something with a 10% error rate. Let me go look at what is causing this errors. Let me try to understand this. So, oops, this last 6 hours. Let's do 15 minutes. OK, there you go. So here you have basic red dashboards, the logs and traces for that application. And here I can see that, OK, this product catalog, get product is the one that's causing all these errors. So let me try to go and take a look at the traces for this. So this gives all the traces. Let me do error equals true. This is pure Jaeger. Again, you need to learn Jaeger if you want to use this APM product, that you can't get around it. And I'm seeing a bunch of requests. So let me open a trace. OK, so here, this is the trace for this. And yeah, so basically, the error is there's a fail feature flag enabled. Again, I intentionally set up the demo to fail so that there's some errors. But this is basically how you can kind of have a basic APM. One interesting sidebar is, every time I run this thing, there is a clock skew happening in my traces, and it goes up to minutes and even hours. So every time I have to restart my thing, and I have no idea why this is happening. But anyways, let's look at some other integration. So I don't know. Oh, we have the add service. I'm going to try and look at some of the failures in the add service. And I can see kind of what's happening here. It says resource exhausted. I don't know what that means, but basically I can use this to debug. One of the things I did here is jump from logs to traces. And this is only possible because of the consistent metadata that OpenTelemetry embeds into its logs, that I can correlate between logs and traces. I can similarly correlate between metrics and traces with exemplars. Exemplars are fully supported. Having said that, there's a bug in the OpenTelemetry collector that is not letting me use exemplars. I have to go back to an older version, which doesn't have some of the features. So again, it's a huge work in progress. But yeah, even you can jump from metrics to traces using exemplars as well. So yeah, that is the basic demo. This doesn't look super fancy, but again, we at Grafana, we're working on making sure this is a consistent, coherent experience if you're using OpenTelemetry with Grafana. Yeah, if you want more details about that, find me after the talk. Cool. Going back to the slides that we've seen the demo, there are some caveats to this whole thing. First thing is, OpenTelemetry is still super early in its journey. So the metrics part is super stable. You can use metrics with Anger, and all of that still works. The traces part is super it works quite well. You can use the traces with anger and everything works. The metrics has just been stabilized in terms of specs, which means not all languages and not all SDKs implement the metrics and semantic conventions around metrics. I needed to get the same set of metrics for every service, so I basically used the traces to generate the metrics. But there's a huge push in the OpenTelemetry community on stabilizing the semantic conventions, which define what metrics should be exposed by the SDKs. And that's happening right now. The first thing they're doing is HTTP conventions. And once that is done, the next thing is implementing them in the SDKs. So that way I can directly use the metrics themselves instead of using traces. Similarly, the semantic conventions are being driven around resource utilization, so I can also look at memory, CPU graphs of this. Profiling is on its way, so you can also use profiling to understand how your applications are behaving. I would say logging is pretty early. You saw a nice logging panel in the demo. Having said that, only one service exports these logs. So for all services, I put the same services logs. It's still pretty early in its journey. Having said that, Java is working, and soon other SDKs will start working. I would say, all in all, if you want to build an APM on top of OpenTelemetry, I would wait around 6 months. Having said that, participate in the semantic conventions, make sure the semantic conventions being stabilized, they work for your applications and for your use cases. I think the overall vision is awesome. There's a lot of value in having this standard, adopted by everyone. For example, imagine this. You have like 5 or 6 libraries that you import, and all 5 or 6 libraries are instrumented with OpenTelemetry. So when the whole world is instrumented with OpenTelemetry, things start to get like brilliant. When everyone is using the same semantic conventions, you can go from vendor A to vendor B, and you can build automation on top of these semantic conventions that let you do all of this. The vision is awesome. And we're like roughly 6 months away from the first from where you can use it in the form of metrics and logs. If you want to make it faster, get involved, start contributing. And that's the end of my talk. Any questions?